Welcome back, everyone, to lecture 13, where we're talking about polynomials today instead of monomials. Okay, so a polynomial, similar to a monomial, is an expression involving numbers and variables with only positive integer coefficients, no fraction integer coefficient, or no fraction coefficients, or negative exponents. Or I'm sorry, it should say positive integer exponents. That's what I meant to say. No fractional exponents and no negative exponents. The different monomials within the polynomial, because a polynomial is just a bunch of monomials connected to each other, are combined via addition or subtraction, and the terms within the monomials can be combined with multiplication. If they are combined, if any of these like multiple terms are combined with division, it can become a rational expression, which is not the same. But a binomial is two monomials. A trinomial is three monomials combined together. Those, I guess, if they ask you to classify the polynomial, they could be classified like a binomial, trinomial, or the expression for four or more monomials is still polynomial. But they might ask you to do classify it if there's two or three of them. And then the degree of a polynomial is the largest exponent of any given monomial in the polynomial expression. If there are multiple variables involved, you have to add the different exponents of the different variables in each monomial expression and see which one is largest, which we'll see later on. Okay, so moving on from here. 10 plus 6 times the square root of b is a polynomial. Well, this can be written as 10 plus 6b to the 1/2 power. That is a fractional exponent. That is not a positive integer exponent. So this is not a polynomial. So this would be false. Okay, so next one we have z cubed minus 16z to the 4th plus z squared. So we have three different monomials, all combined with addition and subtraction. In this part, sorry, I worded this kind of poorly up here. The multiplication only applies to how the monomials are combined, like 16 times z to the 4th. But the different monomials in a polynomial are combined with addition and subtraction. So I apologize for that slight miswording there. That's what I meant by that. I just didn't word it the best at that particular juncture. I was thinking about that before I started. So this is in fact polynomial because it's three monomials combined with addition and subtraction. The monomials themselves are combined with multiplication. If they were combined with division, like say this was like 16 over z to the 4th. As we know from our exponent rules, we could write this as 16z to the negative 4th, which gives us negative exponent, which is not allowed. It has to be a positive integer exponent. But this checks off all the boxes, so this is true. It is a polynomial. Now, in number 3, that's what I was talking about. If the terms are combined with division, we have a binomial in the top, we have a binomial in the bottom or in the numerator and denominator, but they're combined with division. So this becomes a rational expression. So no, it's not a polynomial. So that's false. Okay, so in this one, we have to find the degree of the polynomial. As we said, it's the degree is the largest exponent of the variable, or in this case, variables. So we have to add the exponents of these variables together in each different monomial and see which one's the largest. And you don't include the coefficient exponent, only the variable exponent in the degree. So no coefficient exponent. You only consider the exponents of the variables. So this one, the exponent sum to 8, and this one the exponents also sum to 8. So I'm sorry, sum to 8, and in this one they sum to 9. And be careful there because there is the exponent of 1 for c, because that's what all of them carry if they are already stated. So the degree of this polynomial would be 9, because the largest degree of any of these monomials is 9. Okay, so next one's another true or false. 5 minus 6p to the fourth is a binomial of degree 4. Okay, so binomial, as I mentioned up there, is two monomials. Well, that's true. We have 5 and 6p to the fourth. They're combined by subtraction, so that would make it, a binomial. There's 2 terms, and the degree is the largest exponent, which is 4. So the degree is 4. It's a binomial and degree 4, so this is true. Checks off both boxes. Okay, so one thing to note about whole numbers here and not variables is that they have degree 0. So this is not degree 1. The number 7, any number that's not expressed as variable, has degree 0, and that's why it doesn't count towards the degree of the rest, or of the monomials that we calculated up there before. So this one is false. Okay, the next one says classify the polynomial after combining like terms. Okay, so for combining like terms, we have to look for all of the same terms here, where the different variables have the same exponents, and that would be the quote unquote like terms. Okay, which it appears here there's only one of those like that, because this one has v squared uw, this one also has v squared uw, whereas the other two, this has u squared vw, this has u squared vw cubed. Those are not the same. The w's have different exponents, so you can't combine them, but we can combine the ones that are underlined in pink. So what we do to combine those is we consider the v squared uw's as like a group, and then we just consider how many of them we have. Well, we have 13 minus 13, so those actually cancel each other out and they go away. So our new expression is negative 8 u squared vw plus 4 u squared vw cubed. Okay, and now we just consider the degree like we did before. We have, if you consider that these also have degree 1, the degree of this monomial would be 2 plus 1 plus 1, which is 4, and the degree of this one would be 2 plus 1 plus 3, which is 6. So the highest degree wins of 6. And also take note that, oops, excuse me, sorry for that, that there are 2 terms. The negative 8u squared vw is one term, then plus the 4u squared vw cubed is the second term. So it's a polynomial with 2 terms, or a polynomial with 2 monomials. It's a combination of 2 monomials, so this would be a binomial. That would be classifying it. Classify the polynomial. It is a binomial. And then it would have, if it asked further, it would have degree 6. But it is a binomial. And that is how you would classify it. I hope that helped, and I will talk to you in the next video. Thank you.